So the last lesson that we're going to be doing for Unit 4 is continuing actually to look at percent error, which we've already started looking at. We've delved a little bit more into it, and this is going to wrap it up for this unit. So, first thing we have is that a student estimated that it would take 3 hours. So the estimate is 3 hours to write a book report. It actually took her 5 hours. Oh, this sounds like most of my students. They think it's going to take less time to do something than it does, so they don't leave enough time. I'm sure that's none of the students that are listening to this right now, because none of you would do that. Those are some other students I must be remembering. Anyway, we're looking for the percent error. So the first thing we're going to do is find out what the error or the difference is between the actual and the estimate. So 5 minus 3, of course, is 2. That's the 2 hours is the error. And that means, now don't forget, we always have error over the original, or the actual, I should say, not the original, the actual. And that's equal to the percent over 100. So we know that that's what we're always going to be using. So the error in this case was 2. The actual was 5. And that's equal to some percent we don't know over 100. And we've been doing so many of these. I'm sure that you know by now that what you're going to be doing is cross-multiplying to solve these. So that means I'm going to have 5 times x equals 2 times 100. 5 times x is 5x. 2 times 100 is 200. The opposite of times 5 is divide by 5, so I'm going to divide both sides by 5. Those two cancel. I'm left with x equals, well, 5 goes into 20 4 times with another 0 there, because that's where it is, right there. So the percent error in this case is 40%. Next problem, we have a radar gun measuring the speed of a baseball at 103 miles per hour. Okay, that's the measurement. The baseball was actually going 102.8 miles per hour. What is the percent error? So again, first thing we're going to do is we're going to find the difference. So the difference in this case is 103 minus 102.8, or 102 and 8 tenths. Or if you like to think about it like money, because a lot of times that makes it clearer for most of us, we think that about is $103 and $102.80. So of course the difference in this case is going to be 0.2 or 2 tenths. So that is our error. We're looking for the percent. So that means our error, 0.2, goes on top of the actual, which in this case the actual was the 102.8, and my percent is always out of 100. I, as always, am going to be cross-multiplying. So that means I'm going to have 102, whoops, that is still in my highlighter, 102.8 times x equals 0.2 times 100. So 102.8 times x, of course, is 102.8x, and that is equal to 2 tenths times 100 is 20. The opposite of multiplication is division. I'm going to be dividing both sides by 102.8. These two cancel. I'm left with x equals, I get this funny answer of 0.19455, and it goes on. Again, per usual, my usual go-to would be to the hundredths place. We look at the 4, that is less than 5. That means we're rounding down. So that means it's going to be 0.19455. If we round down, it stays the same, so it's 0.19%, or a little less than 2%. Next, a farmer estimated that there were 25 gallons of water left in the tank. So there we have our estimate, 25 gallons of water. If this is an underestimate by 16%, how much water was actually in the tank? So what they're saying to us is that we really want to make sure we think about this. It's an underestimate. So that means that the 25 gallons is less than what's actually in there. So we want to think about this is that 25 gallon estimate is 16% less than some number will make X. So you see how we did that? The 25 is the estimate, and we know it's 16% less than some number we're not sure of. So if I know it's less than, I'm going to think about it as my original being my 100%. I'm going to take away that 16 because it's 16% less than the 100%. So that, of course, is going to be 84. Not today. Today, it's and every day, it's going to actually be, wait, what? Oh my goodness, I'm going crazy. 84%. I don't know what I was thinking there. So that tells us that, let's change this again, our statement here. So it says 25 is 84% of X. So it's X that we don't know. So that tells us that 25 is, that goes on top. 25, the of, we don't know, X on the bottom. The percent is 84, always out of 100. So if I cross multiply, I am therefore going to have 84 times X equals 25 times 100. 84 times X is 84X. 25 times 100 is 2,500, or 2,500. The opposite of times 84 is to divide by 84. These two cancel. I'm left with X equals 29.761. I'm going to round that to, let's see, if I round to where the 7 is, I look at the 6, that's above 5, so I'm going to be rounding up. That means the 7 goes up to 8, so my answer is going to be 29.8 gallons of water. Our last problem. We were doing these before. It's nice to go back to them to make sure we don't forget. Each story we're going to write an equation that describes the relationship between the two quantities. Okay, so Diego collected X kilograms of recycling and Lynn collected 2/5 more. So first of all, I want to write up here, please don't forget that whenever we write an equation, it's always in the form of y equals kx. K is the COP, constant proportionality, that number that everything gets multiplied by. So, Lynn collected 2/5 more. So, 2/5 more, X is our original, so we've got 1. More means we add 1 plus 2/5. We can write that as 1 2/5. Or typically when we write these, we like them to be simply a fraction, in this case an improper fraction. 5 times 1 is 5, plus 2 more is 7/5. If you'd use the 1 2/5, it's not wrong. But this is, again, typically the way that they're written. So we're going to use this in our equation. So we've got y equals, this is our k, 7/5 x. There's our answer for the first one. Okay, next. Lynn biked X kilometers, and Diego biked 3/10 less than that. So our original X is 1. 3/10 less means I'm subtracting or taking away 3/10. Remember, 1 whole is 10/10. So 1 whole or 10/10 minus 3/10 is going to give us 7/10. So this is what I'm going to use. I'm going to use my format, y equals 7/10 x. I'll go for the second one. And the last one. Diego read for x minutes. Lynn read 4/7 of that. Now be careful, because this doesn't say less than, this doesn't say more than, it says 4/7 of that. So in this case, our 4/7 is going to be our k. We don't need to do any manipulation of those numbers. It's going to have y equals 4/7 x.